they're single-celled organisms which reproduce rapidly in favorable conditions. So they generally reproduce through mitosis. And another example is E. coli or Listeria monocytogenes. So in food safety, some are harmful and these are helpful, is effectively what we're getting at. Viruses are much smaller than bacteria. They're intracellular parasites, meaning they require a living host to replicate. So notable examples are like norovirus and hepatitis A. In food safety, they can cause gastrointestinal illnesses or tummy aches when present in contaminated food or water, or like I said before, ice cubes. Parasites are multicellular organisms that live on or outside a host organism, and they derive nutrients at the host's expense. So examples of that include Giardia or Toxoplasma. They can contaminate food and cause a parasitic infection in humans, especially when hygiene and food handling practices are poor. The protozoa are single-celled organisms capable of movement and consuming organic matter. So they're a little bit more advanced. They're more what we would almost consider an organism as opposed to cellular, but they're still microscopic in size. An example is Cryptosporidium or Cyclospora, which cause diarrhea, illnesses, and stick around for a fairly long time. Fungi like molds or yeast are eukaryotic organisms that usually include molds, yeast, as I just said. Like example is Aspergillus, which is a type of mold that can produce toxins, while a candida is a yeast. Molds can produce mycotoxins that contaminate food, while yeasts can be useful in fermentation. It's noted that penicillin also has its origins in various types of fungi, so they can be also very helpful or very pathogenic. So in order to prevent microbial growth in food, you need several strategies, including proper hygiene practices like hand washing and glove use and sanitizing surfaces, which can help to prevent cross-contamination. But you also need proper temperature control, as cooking food to the right internal temperature kills pathogens before they can infect a community member. Adjusting pH levels can inhibit bacterial growth, especially in acidic foods like pickles. Monitoring water activity is important, as high moisture content promotes microbial growth. Preservatives like sugar, salt, vinegar also can reduce some of the risks. But regular sanitizing of food contact equipment and surfaces and hand washing are generally the best defenses against microbial growth and propagation. So some of the more common sources, generally they come from a variety of places, like raw, undercooked foods that can harbor bacteria, such as ground beef containing E. coli. Contaminated water supplies can introduce pathogens like Vibrio cholerae, or one of the others we had just mentioned, like Giardia, which can cause various illnesses. Food handlers with poor hygiene can transfer microorganisms through practices like not washing their hands or like touching themselves in inappropriate places like their face or nose or eyes while handling food. Animals transmit zoonotic diseases. For example, handling raw poultry or raw animals can spread Salmonella and E. coli as they get contaminants from the environment all over their fur or feathers or skin. Spore-forming bacteria, again, they're capable of producing dominant spores that can survive extreme conditions, including heat and dryness. Some, again, examples, the botulism toxin and Bacillus cereus like to cover themselves in spores and protect themselves in canned goods until they get just enough oxygen to trigger their germination process. So once they get into an anaerobic environment, they form that spore and the protective coating, and they defend themselves until they can get enough air to get started again. So foodborne intoxication happens when toxins produced by the bacteria are ingested through contaminated food. So unlike an infection, where you've taken in the live bacteria. You haven't taken in anything live, you've just taken in the toxins they produced while they were there. So only the toxin that previously produced needs to be consumed. For example, Staphylococcus aureus can produce toxins in dairy products that were not stored or handled properly. So even after cooking with all the bacteria destroyed, the toxins can still cause an illness. We also have carriers, who are individuals who harbor and shed pathogens without showing signs of illness themselves. These individuals can transmit disease to others, particularly through food. A common example is someone carrying the hepatitis A virus who prepares food without proper hand hygiene, potentially causing an outbreak. One of the most famous examples is Typhoid Mary, who worked as a cook in several wealthy households. So she was permanently infected with Salmonella bacteria, and every time she went to cook at someone's house, she would make everyone else ill, but she herself never presented any symptoms. So identifying and managing carriers can be difficult, but it's also important. So if you are a known carrier, you have to have documentation, and you're not really supposed to be working in food handling in certain environments. And if you are going to be working in those environments, there need to be certain safety precautions put in place. So the temperature danger zone is the zone between 4 degrees and 60 degrees. So this area is known as the danger zone because pathogens can grow rapidly within that temperature range. Is the most comfortable for them. So in ideal conditions, these bacteria can double in number almost every 20 minutes. So with proper cooking and proper cooling, you can make sure that the food is kind of kept out of the temperature danger zone and kept out of that range. Freezing, while it doesn't kill the pathogens, it does slow their growth significantly. So when foods are thawed, the bacteria is still there, so you have to make sure that you're thawing those foods at an appropriate rate and an appropriate way. So we're going to get into some of the things that can help affect pathogenic growth, like nitrogen, nutrients, for example. Microbes thrive in protein-rich and moist foods. Their cells like to use all these nutrients in order to get the materials they need to grow, divide, and to reproduce. So the key here is to properly store, prepare, and cook any foods that are nutrient-rich, like proteinaceous foods like cheese or milks or meats, in order to make sure that any cells that are there are going to be properly killed off. The pH of a food product is a measure of its acidity or alkalinity. So its values go usually between 0 to 14. 0 being the more acidic and the 14 being more alkaline. So most bacteria prefer a near neutral pH level, so they grow optimally at a 7 pH. So while acidic environments below 4.6 can inhibit some growth and are especially effective with most pathogens. So vinegar, for example, which has a pH of about 2.5, is used to preserve pickles and salad dressings because of that acidity that prevents bacterial growth. Water activity is the amount of moisture or water available in a product, which is not being bound up in the product itself. So we're looking at things like that have high moisture content, like deli meats, fresh fruits, and vegetables that are more susceptible to spoilage by bacteria and fungi because they have more moisture. So dry foods like your jerkies or dry goods are usually a little bit more safe because they have low water activity and are less likely to support microbial growth. Oxygen is important, and with the exception of some few anaerobic bacteria, most aerobic bacteria, like Pseudomonas, require oxygen to survive, and that's like most bacteria or most microbes require oxygen to survive and can be found in open air environments. So anaerobic bacteria, like Clostridium, don't necessarily need as much oxygen and can thrive in a vacuum-sealed environment. So that's why you really need to make sure that you're really cooking canned foods appropriately, because the botulism toxin can stay in that can for a very, very long time. It's also make sure that the packaging and storage practices account for oxygen levels. So make sure that the cans are all in solid condition, that there's no dents or tears or rips, and that all other kind of modified atmosphere packaging is all intact. Potentially hazardous foods are the items that support the rapid growth of microorganisms, and so they have to be handled carefully. The foods are high in protein. They usually have the perfect acidity, the right temperature, the right oxygen level, the right water activity. All of these things help to make a food more potentially hazardous. Um, and the more potentially hazardous foods are things that are protein rich, like soups, stews, dairy products, such as milk and cheese, as well as anything really high protein, like fish, meat, or eggs. Your cooked vegetables with high water activity, some raw fruits and vegetables, and sprouts and melons and sushis made with raw fish also fall into the category. So it's important to keep the food within that proper temperature range, within the proper acidity range and water activity, just to make sure we don't have runaway growth of microbes. Some of our more common sources of microorganisms include your raw meats, your seafoods, your unpasteurized dairy, contaminated water. It comes from sources include like bad hygiene, that's personal and animal and environmental, as well as from animals within the environment. So the consistent application of control measures is essential for ensuring that food is safe to consume, and being aware of the various sources and types of microorganisms and how they develop helps to ensure effective prevention strategies. Factors such as temperature, moisture, pH, and oxygen should be regularly monitored and adjusted to prevent microbial growth. And by understanding these factors and taking appropriate action, food handlers can effectively manage the risks of contamination and protect their food supplies.